This lesson is focused on two things. The first one will be to solve inequalities using a graph and tying that into what we've talked about before with positive and negative intervals, and then also using the graphing calculator function to solve equations by using the intersect key. So let's start with, first of all, solving inequalities. If we have a graph, an f of x graph, really when we're doing an inequality, if it's saying solve f of x greater than 0, what we're really just asking is, when is this graph have a positive interval? And then when it's less than 0, when does it have a negative interval? So if we just summarize it, this would be positive intervals sometimes there's just one positive interval, sometimes there's more. This would be negative intervals. So on this one with the positive, if you look at this, we're going to look at when are these graphs positive. So looking at this one, notice it's positive from -3 and below. That's going to be x is less than -3. If we were to list that as a interval, we go from negative infinity to -3, and then we'd stop. Now remember, -3 is a 0, so it's not going to be a positive interval. Now the other one is from x is greater than 1. And so that interval would be 1, infinity, where it would go. Okay, we'll do the same thing with the negative intervals. If we're looking for when this is going to be negative, this part here from -3 to +1 is when we have a negative interval. So that turns into an interval in interval notation, -3, 1 between those two. All right, so let's use this as an example here. We're going to go ahead and talk about these graphs. So notice I've got an absolute value greater than or equal to 0. So what I want to do here is go ahead and graph this. And so to graph it, let's scroll a little bit. So to graph it, I'm going to go ahead and use my translations on this one. So if this is going to say move it over 5 units positive, so 1, 2, 3, 4, 5, and then move it down 2 units, 1, 2, and the vertex of it will be right there at 5, -2. All right, now if I were to go ahead and draw this one out, it would go like this, and it would go like this. So it would cross here at 7, and it would cross here at 3. Think about what that means here. 3 minus 5 is -2. Absolute value is 2. 2 minus 2 is equal to 0. So that's when it crosses the axis. So what we're going to look for here is, when is this graph a positive interval? And what we're going to add in here is, we're going to add the fact that if you've got an or equal to on this one, include the point when you have an or equal to. So when you have either greater than or equal to or less than or equal to. So for this one, notice that greater than or equal to 0, it's this part over here and this part over here. Those intervals are going to be, this one will be from -infinity to 3, and we're going to include the 3 because of the or equal to, and this one will be from 7 included all the way to infinity. let's try this one over here. This one is just a straight line. So I'm going to start this one at -5, my y-intercept. Then I'm going to use a slope of 5. So I'm going to start here at -5, or excuse me, at -5 for my y-intercept. We go up 5 for my slope, 1, 2, 3, 4, 5, and over 1. That gives me my intersection point. I draw the line, so this is just the graph of, really what we're graphing for this one is y equals 5x minus 5. Just like over here, we graphed y equals the absolute value of x minus 5 minus 2. So we graphed that one, saw when it was above the axis. This one we're going to see where it's below the axis. So if we were to graph this one, here are the values below the axis. And so for those x, we're looking for the x values. So the x values for this one, that interval, it goes from -infinity, and it goes to +1 for an x value, and it doesn't include it because that one doesn't include it either. So this inequality would be x is less than 1, because those are the x values where this is below the axis for it. Okay, so we've solved those inequalities. Now what we want to look at is how we can use the graphing calculator, the intersect key on it, to find values. Now, this is a nice feature of the graphing calculator. What we're going to do is we're going to set this up into 2 different equations. Y equals x squared minus x, and y equals x plus 2. Now when we do it, let's pull up our graphing calculator, these steps. So what you'll do is go here, turn it on, go to the y equals, I'll put in my first equation. So x squared, I'll put an x in, and then squared, minus x, minus x. And then hit enter, we'll go down to the next line. We're gonna do 2 graphs at the same time. So we'll do y equals x plus 2, okay, for that one. Now what we're looking for is when we hit graph here, okay, so the graph of it, here's the first graph, we're looking for where those 2 graphs cross, this parabola and this line. So how we're going to do that is the graphing calculator can do it for us, because if you look, it's got a calculate key. So if you hit second calculate, let's put those keys here so you know where to look for it. Second, and then calculate, which is right above, if you look at this on the calculator, that's right above the trace key here. And then, so it's second, calculate, and notice you go down to number 5 is intersect. Okay, so we go, number 5 is intersect. Now, the next steps you're just going to have to get used to using. They take a little bit of telling the calculator what it needs to know in order to know what we're intersecting. So I'm going to first of all hit intersect, hit enter, and now it's saying where is the first curve. Now one of them is a line, but it's going to call it a curve. It's saying, hey, this value up here, y equals x squared minus x, is that the first thing we're looking at? Yes, it is. Now you might be saying to yourself, there's only 2 curves there. Why is it asking us? Well, it doesn't know. Maybe it thinks that there's a list of 4 different graphs on here. It wants to know what's the first graph to look at. So here's the first graph. You just hit enter. You just say, okay, go ahead. So you're going to hit enter a bunch of times. What's the second one? Is that the second one? Yep, there it is. I'm going to hit enter. And now what you have to do, you have to guess at about where the intersection is. Okay, it wants to know, because there's 2 of them, it's kind of saying, where do you want to look for this intersection? So hit the side arrow until you get about where they cross. Okay, it's telling us x and y values. That's my guess. I'm going to hit enter again. And notice my intersection then is at -0.73 for x and 1.26 for y. So I'm going to put negative 0.7 and 1.3. Okay, so our first one will be at negative 0.7 and 1.3. Just make sure that's what my answer is. So rounding this one to negative 0.7 and 1.3 for my first answer to this one. Okay? That's impressive to solve this quadratic using graphing calculator. Let's find the second one. Okay, now the second one, all right, so the second one, we found that intersection now. We got to go ahead and hit second, calculate again, go down to intersect. So we're going to just repeat this, hit enter, and now our first curve is that parabola. Yep, hit enter again. Second curve is that line. Yep, just hit enter again. So you hit enter a few times. But when it comes with the guess, we're going to go over by that other one. We want to guess the other answer. So you're going to go ahead and arrow over to this one, hit enter, and then it gives me a new intersection point. The second one will be 2.7 and 4.7. 2.7 and 4.7 for my second point of intersection. So intersecting a parabola and a line, we can use this intersect key, this sequence. We have to follow through and get used to doing it because you have to hit enter a few times and do a guess. But that will give you estimates of what those graphs, what those intersection points are on your graphing calculator. So we can use our graphs to do inequalities by using positive intervals or negative intervals according to whether it's a greater than or a less than. We can use the graphs in that instance. We can also use the graphs to solve more complex problems and get estimates of the answer using the graphing calculator.